First, a couple of vocabulary things. A system is just a set of two or more equations. A set of two or more equations. So in Algebra 1, we really just dealt with two equations, and they were both linear. By that I mean they just both had an x and a y in them. Okay, and so that's like the first example that we would do. In pre-calculus later on, we're going to introduce three sets of equations with three variables. And so the ways that we can solve that involve matrices. So we're going to use some matrices to do that. In a little different way than you did before. So we touch on matrices, but not nearly as much as you did in Algebra 2. The solution, just like we talked about, are the ordered pairs, and I'm put the S in parentheses because I'm going to talk about how one is at one or multiple, that make all equations true. In the example we did in our opener, how many solutions did that have? Three. And the reason why there were three was because one of the functions was a cubic function. Okay, so if we have two, let's just review, if we have two linear, or two lines, a linear system, what could happen? So one thing that could happen is that they would intersect. Then that would have one solution. It is an ordered pair, so it's two numbers, okay? Or what else could happen is that the lines are parallel. In that case, there would be no solution. And then the third thing that could happen is they could be the same line. We call that a coincident system, okay? So then that has infinitely many solutions. Okay. Is that sounding a little familiar? Okay. So tomorrow we're going to talk about elimination, and I would say the majority of the time when you have linear systems and they look like this, I would use elimination. But I'm going to show you how you could use substitution. So substitution, the concept basically is you get one variable by itself and then you substitute that expression into the other. So either one would work. I could get y alone up here pretty easily, or I could get x alone down here pretty easily. So let's say I chose the top equation and I got y alone, then I would have y equals 20 minus 3x. So for substitution, it's just like I would explain it in my algebra classes. It's like when you substitute into a game. Somebody comes out, and then somebody goes in their place. So in this equation, the y is going to come out, and this whole expression is going to go in its place. But notice, what am I doing to y down here? I'm multiplying it by 2, so I need to make sure that I multiply that expression by 2. So what I like to do is just put it in as a parenthesis. So x minus 2, that's where the y was, and now I'm going to put what y equals in that spot. And then let's solve for x. So x minus 40 plus 3x equals 10. Oh, it would be 6x, sorry. Sheeshers. Alright, then I add like terms together, so 1x and 6x is 7x minus 40 equals 10. So 7x equals 50. And then I'm going to just leave it as a fraction. X equals 50 over 7, which is the same as 7 and 1/7. Okay, so I just found the x coordinate, now I need to find the y coordinate. So I'm going to sub that back in, I'll just do that on up here. I'm trying to get my space organized. Alright, so I'm going to write 50 over 7 minus 2y equals 10, which can I write that as 10 over 1? Okay? And so what I'm going to do is, because I'm going to be moving a 7th to the other side, I'm going to just multiply this by 7 over 7. And then I'm going to subtract 57ths from both sides. So now I have what's going to be left on the side? Negative 2y equals 70 over 7 and minus 50 over 7. Which is okay, wait, I have to simplify it. Isn't that 27? Yep. So now I divide it by negative 2, which is the same as multiplying by negative 1/2. So y equals negative 10/7. So my solution is 7 and 1/7, and then what would that be as a mixed fraction? Negative 1/7. Okay, so I picked one that was with fractions for a reason. Substitution is a algebra 1 thing, so you've learned it before. So we should be able to do kind of messier stuff, right? Use some fractions. It's a really algebraic section. Let's skip this, we'll come back to it. I'm going to show you something that is non-linear. So solve the non-linear system algebraically, and this looks actually it's the same exact one. Huh. How would I solve that algebraically? So I have y equals 3x and y equals x cubed minus 6x. So I'm going to take out either, it doesn't matter where you want to do it, I'm going to take out one of the y's, and I'm going to replace it with either a 3x or an x cubed minus 6x. Alright, so if I took out the y down here, what would I put in its spot? X cubed minus 6x. Alright, now, let's just review the way to solve different equations. If it's quadratic, this is too big. If it's quadratic, we want to get everything on one side and set it equal to 0, and then what are our options? Quad formula or factoring if it's factorable, okay? If it's a cubing function, the only way we know how to solve that algebraically is zero product property. So if it doesn't really factor or we can't get it to factor, then we can't solve it algebraically. So let's try to factor it and see what happens. If I subtracted 3x from both sides, wouldn't I get x cubed minus 9x? Okay, so then I'm going to take out an x. And what's left? X squared minus 9. And then you have, I like to factor further just because then we can talk about it. You can set this equal to 0 because we can use a square root to solve it. But this is also a difference of squares, so I could factor it like this. Hopefully you're seeing now those 3 x values that occurred in our opener. If I set each of these equal to 0, I would get x equals 0, x equals 3, and x equals negative 3. Alright, so now we plug them in either equation. Which one looks like it's easiest to work with? The bottom one. Yeah, I mean, you can put it in either because remember the solution has to work in both. If I plugged it in here, I see that y is equal to 0, so that's my first ordered pair 0, 0. If I plugged 3 in, I get a 9. And if I plug negative 3 in, I get a negative 9. Okay. So let's take a look at the rectangular garden one. So find the dimensions of a rectangular garden with perimeter 100 feet and area 300 square feet. We've actually done this one before, earlier on when we did rational functions. But we're going to do substitution and make it linear and quadratic. So how do I do a perimeter of 100? Thinking that the dimensions are x and y of the rectangle. Good. 2x plus 2y equals 100. And then the area would be x times y equals 300. So I'm going to actually take the top, and I'm going to divide both sides by 2. I'm going to use some substitution here. If I did that, so this is my system, wouldn't I get x plus y equals 50 if I divided both sides by 2? Okay. And then further, if I was trying to get one variable alone, we could get y equals 50 minus x. Okay. So now what can we do in the bottom equation? Yep, we're going to take out this y and replace it with 50 minus x. So we do that. So I have x times 50 minus x equals 300. Okay, so this one is quadratic. So I'm going to move everything to one side. I don't really like having negative x squared, so what I'm going to do is move these two things to the right side, which leaves me with x positive x squared minus 50x plus 300. Okay, so again, remember our options are factoring. This is kind of a big number. I actually don't know if it factors or not. But I'm going to just, so we review it, do quad formula. So let's flip over to the back so we have some more space. So A is the coefficient of x squared, B is the coefficient of x, and this is C. Does anybody remember the song? You do or you don't? No, you never had the song. X, you probably didn't have. Yeah, there you go. X equals negative b, or plus or minus square root b squared minus 4ac all over 2a. Okay, so let's just do what's underneath the radical. By the way, what's going to happen to negative 50 when you square it? Yeah. So alright, so when working with quad formula, you want to simplify what's under the square root. We're going to take the square root of it. Let's remember that it's the whole numerator that's divided by 2. So the square root of 1300, we'll call it 36.056. So I get 43.028 for one of them. And 6.972 for the other. If you would put those back into the two equations, actually what you would find, I believe, let's double check, is that this is the x and this happens to be the y, so there's actually two intersection points, this comma this and this comma that, but for our purposes in a rectangle we just need the two dimensions. But let's just double check that these two things, when we multiply them together, give us the area. Close enough because we rounded. Okay? So the dimensions of the rectangle then would be 43.028 feet by 6.972 feet. Okay, so